Okay, as a quick heads up to anybody that might be watching this on YouTube, I'm actually doing this to help out students that I'm working with personally, but I'm posting it on YouTube in case this could be of help to anybody else. Now, I'm going to give you a quick introduction to what the whole picture is, but we're going to focus on just a small part of that picture, and that's dealing with side angle triangles like this. I know one side, I know another side, and I know one of those angles, using the law of sines to find out what two possible triangles and their measurements could be using the law of sines and using the unit circle down here. Now, that's the whole purpose of this video. Let me give you a little bit more background for those of you that may be watching this so that you understand that I'm only showing you one piece of the picture here and not the total picture. When you use the law of sines, you're dealing with oftentimes triangles that are angle, side, angle, or side, angle triangles. Now, in the case of an angle, side triangle or an angle, side, angle triangle, there's only one possible triangle that can come out of that. The reason being that you have two angles that are given. So when you find a third angle, it can only be one number. It can only be one value. It's not going to change. However, when you're dealing with side angle triangles, it turns out that there could be three possible ways this could go. You could either have, for your number of triangles, 0 triangles. You could have only one possible type of triangle that could come out of this, or you could have two different types of triangles that come out of the values you're given, like this here. This video is focusing on simply the case of side angle triangles where we have two solutions. This gets a lot deeper when you're doing this in the whole of learning trigonometry and the law of sines in general. So what I mean by this is most of the time, if you're given the measurements of a triangle, you will be expected to know how to find out how many triangles there are. For the purposes of teaching you how to find out what those two solutions are, I'm going to simplify it and tell you that in these two examples I'm going to show you, there are two solutions. Again, this gets more in depth because you will be expected to find out on your own how many different numbers of triangles there could be in a side angle situation. Okay? So this is meant to give you practice understanding how it is you find that second triangle, how it is that these three measurements using the law of sines can actually lead you to a second possible triangle. And the other purpose is it's meant to give you a little bit of practice with this thing we call the unit circle here, which is of the utmost importance to trigonometry. This is the foundation of trigonometry. If you do not understand the unit circle, this is like me putting you into a college algebra class and you don't know how to add and subtract and you don't know your times tables. If you do not understand the unit circle, it will kill you. Okay. Now that I've gotten through all the disclaimers here, let's go through our first problem. I have a side angle triangle, and I've already told you for the terms of practicing this, there's going to be two possible solutions here. So what I typically do when I start these things out is I draw a triangle that is absolutely not to scale, all right? I'm doing this to make it easier so when I write all my information down, it's easier for me to see. I also typically label my triangles angle A, angle B, and angle C. This is a personal preference. You can do it any way you want. Now that we've got that out of the way, I'm going to go ahead and fill in the information I know given on this triangle. I know that my angle A is 25 degrees. I know that my side A, which is opposite of angle A, is 125 units of some kind. They didn't tell us. And I know that my side B is 150 units. So what I'm going to do right now is I'm going to start using the law of sines to actually figure out what the rest of the measurements could be. And the law of sines is simply this. if I find out what the sine of some angle is and I write it as a ratio over the side length, in other words, sine of 25 degrees over 125, that's going to give me some kind of number over another kind of number. And the law of sines, when you write it out fully, let me get a little more room here, looks like this. Whatever numbers these reduce to as a fraction, as a ratio, if I have another angle and then another side, the law of sines says that these numbers will basically be the same. Whether I have sine of A over side A, sine of B over side B, or sine of angle C over side C, they're all equal to one another. And the thing that's really cool about the law of sines is knowing this relationship right here helps you to find your missing values. So again, we're using this as an example of not just practicing with the law of sines, but especially in this case where you have two possible solutions. Okay, so let me set this up. And by the way, something else I do to make my life a lot easier. Your paper will end up with all kinds of stuff written all over it by the end of solving one of these problems. These problems take time to do. To keep things organized, I always write what it is I'm solving for before I start writing a bunch of stuff down. It keeps it organized. It helps me if I need to go back and take a look and find certain information. I'm going to be solving for angle B over here. So what I'm going to write is for angle B. That way I know what I'm doing, and you'll see how I progress through the rest of this as to what I mean. So I'm going to start my ratios here. I'm going to use sine of angle A over side A equals sine of angle B over side B. The reason I'm going to use that is I know what angle A is for its angle, I know what side A is for its side length, and I know one of the pieces of information for my ratio sine B over side B, which is the side of B. So I'm going to plug in these values. I get sine of 25 degrees over 125 equals sine of angle B over side B. Now when I plug this into my calculator, I'm going to get a decimal value out of it. And that decimal value in this case is going to be 0.0034 if I just round it out to the 10,000th place on my calculator. So by simplifying this, I know that sine 25 degrees over 125 gives me 0.0034. That is equal, and I probably should have put in my side length here. That is equal to sine of angle B over 150. Once I've gotten to this point, it's simple algebra. Now I can go ahead and start trying to figure out what this angle B is. To do that, in this case, I'm going to multiply both sides by 150 so I can get sine of angle B by itself. And if you can hear that, you know that I have dogs. And dogs are definitely a mixed blessing, especially if you have more than one. Okay, to get back to the matter at hand here. I have 150 times 0.0034. And when I plug that into my calculator, I am going to get a value of approximately 0.51 is equal to sine of angle B. And now that I'm at this point, I can find out what my angle B is simply by using the inverse of the sine function, plugging in this 0.51 and setting it equal to angle B. And when I plug in sine of 0.51 into my calculator, and let me use my language a little more correctly here, if I plug in the inverse sine of 0.51 into my calculator, I end up with a value that if I round it out is 30.7 degrees. Okay, this is where we have to stop. I'm going to put this in here for the time being, 30.7 degrees. Here's the question I want to ask. If you get to this point and you say to yourself, okay, if I look at the unit circle and I go to approximately 30.7 degrees here on my unit circle, that means that if I were to trace it back down to the x-axis and to the y-axis, I would have some values here. Now, we're not concerned about the x value or the cosine value here, so I'm just going to put in an x here as a placeholder. But I know for a fact that my value along the y-axis, if I trace this point back, is 0.51. That means if I followed the circle up 30.7 degrees, and then I wanted to find out what the coordinates were, the x and y coordinates, or in trigonometry what we call the cosine and the sine coordinates. If I trace that back to the y-axis, it's 0.51. Now here's my question. Is this the only angle on the unit circle that can have a y value of 0.51? And the answer is no. If you took this angle out, this point, this angle, if you followed it all the way up here and you traced it back to the y-axis, would also have a y value or a sine value of 0.51. This is where your two solutions come into play here, because I know that on the unit circle, the sine or the y value of that coordinate is 0.51 for 30.7 degrees, but I also know that that same sine or same y value coordinate is for this angle over here. I have two possible angles that this could be. So what I'm going to do to find out what that angle is I'm simply going to subtract it from 180 degrees. 180, not 186. My handwriting's very bad. I do apologize. If I take 180 and I subtract 30.7, that gives me 149.3 degrees here. So that means my angle here for B could be 30.7 degrees, or it could be 149.3 degrees. So the way you check to make sure that this actually has two possible solutions, and we're not going to get into detail on that because I'm not going to show you any examples of that right now, but you would take this 149, add it to the angle you know, and if it didn't add up to a total of 180 degrees, you would still have room left over for this other angle. If this were something like 170 degrees and I added it to 25 degrees, that would give me, with two angles alone, 195 degrees, and you know that there wouldn't be any room left over for your angle C. Again, that's not the purpose of this. I'm just throwing it out there for people who are going into this at more depth. Here's what I'm going to do. I found out angle B, and now I'm going to put up here for triangle 1. And I'm going to keep this off to the side because I'm going to have to use it to solve a second time to find out what my values could equal for triangle 2. So keeping on with triangle 1, I know I have 25 degrees for angle A. I know I have 30.7 degrees for angle B. And knowing this, I can find my angle C for triangle 1. And that's simply taking 180 degrees and subtracting the sum of 25 degrees plus 30.7 degrees. And if I plug that into my calculator, which I'm going to because I'm lazy and I never trust my own arithmetic. By the way, doing math is not about arithmetic. It is about understanding the process and the concepts behind it. So if you're not an arithmetic person, don't freak out. I'm not either. This would leave me with 124.3 degrees for my angle C. And I'm going to write that in here. 124.3 degrees. Cool, I know two pieces of information now. I have found my angle C, which I didn't know, and by using the law of sines, I have found my angle B that we're using for triangle number 1 here, which we didn't know previously. Which means what I can do now is use the law of sines one more time to find out what this side C is over here. So, for C, this is for triangle 1 still. I'm going to use my law of sines. Now, I'm going to stick with sine of angle A over A, because I already know what those values are, and it's just to make it simple. But you could use sine of B over side B if you wanted to. It's really your personal preference. So I'm going to set up this ratio to be sine of angle A over A equals sine of angle C over side C now. And this is going to give me, by plugging in the values, the same thing. Sine of 25 over 125, which we did up here, equals sine of angle C, which we know is 124.3 over side C, which we don't know. And the same basic deal here. We're going to plug in the numbers. We've already done it once over here. Sine of 25 degrees over 125 gives me 0.0034. So I'm going to use 0.0034 again just to save some time calculating. Equals sine of 124.3 degrees over side C. I need to find out what that 124.3 degrees is, so I'm going to plug that into my trusty calculator here, and that gives me, if I round it off, and I'm simply going to replace this with the number, 0.8261 over C. Now, again, this is where I just use my standard algebra. I'm going to multiply both sides by C so that I can isolate it. These two will cancel out, and that leaves me with 0.0034 times C equals 0.8261. I will go ahead and divide both sides now by 0.0034. And by calculating this out, I will know what side C equals. And in this case, 0.8261 divided by 0.0034 gives me 242.97. And if you're going to round that off, you'd probably have C equals, wow, 243 as your side length. Okay, that's how you find the first pieces of information. You start with a ratio where you have three pieces of information, you use your algebra, and then you figure out what that first angle could be. You go to your unit circle and you say, hang on a second, could another angle have that y coordinate, that 0.51? When you realize that, you put that off to the side because you know you're going to use it later. So I found everything I need for the first solution of this triangle. And what I would do is I would simply come up here and say, okay, I know my side C equals 243 rounded up. I also know that my angle B equals 30.7 degrees in this case, and I know that my angle C equals 124.3 degrees in this case here. But I'm not done. I have to solve again so that I can go ahead and find out what the second triangle is going to be. Now, let me do something here because I did not leave enough room in this example to solve a second time. So let me create some room here. Okay, back to business. This is for triangle 2. So what I'm going to do is I'm going to sketch out everything again with the same information I started with. This is angle A, angle B, angle C. I know my angle A is 25 degrees, and I know that my side B is 150 and my side A is 125. Now, since up here we realized using the unit circle that it could also be 149 degrees, I'm going to plug this in, and hey, I don't have to calculate it again, so cool, that saves me a step. Now, I am going to use these two angles to find out what my angle C equals for triangle 2. Again, I label everything because you can see pretty quickly how everything is going to be a gigantic mess on your paper, and if you ever need to go back and review this information for some reason, it's so much easier to know what it was you did and where instead of trying to search through that mess. This is pretty straightforward. It'd be nice if trig were like this all the time. I'm going to have 180 degrees. minus the sum of 25 degrees and 149.3 degrees. And when I calculate that out, that gives me a difference of 5.7 degrees. That means that angle C can be 5.7 degrees in the other case. Cool. So all I need to do now is find this side C again. And this is where we go back to our law of sines. And I say, okay, for C, and this is for my second triangle here, I'm going to use another trigonometric ratio. I'm going to go ahead and stick with sine of angle A over A equals, and in this case, sine of angle C over C. The reason I'm doing that is because I've already solved for sine of angle A over A, and it just saves me the step of calculating. By plugging these values in, and I'm just doing this to be thorough so that people can follow along a little bit easier, that gives me sine now of 5.7 degrees versus the last problem. Okay, so I know this reduces, or I should say simplifies down to 0.0034 when we round it out to the 10,000ths place on our calculator, just like it did over here. And I need to find out what sine of 5.7 degrees is, and when I plug that into my calculator here, I get sine of 0.57 gives me rounded off 0.0993 over C. So we're going to use our trusty algebra again. I'm going to multiply both sides by C so I can isolate that. That gives me 0.0034 times C equals 0.0993. I'm going to go ahead and divide both sides by 0.0034 so I can isolate the C once more and get it all by itself this time. And that gives me C equals this. So plug that into my calculator, 0.0993 divided by 0.0034, and what I get is 29.2. So I've got 29.2, and guess what? I've got everything I need. So I would come back up to my extra solutions box. It really depends on how your teacher or your professor is going to ask you to show it. They may just ask you to sketch it. They may give you values to fill in here. This is for a high school student, and their teacher is giving them basically a table to fill in here. So I'm going to fill in that table. First thing I know is that C equals 29.2. Don't worry about this. This was an artifact left over here, graphical artifact, when I actually scanned in these images. Okay, I know that my angle C in this case is equal to 5.7 degrees, and then I know that my angle B in this case is 149.3 degrees. And there I go. That's exactly how I do a problem like this when I know ahead of time that it has two solutions. This, again, is meant for practice at finding two solutions and understanding what the unit circle is. Okay, our second example. So if you're still watching this, we are about 23.5 minutes into this video. So the next example should go a little bit quicker because I don't have to explain all of the background information. And if you're still watching, congratulations. That means your head has not exploded from the adrenaline rush of just the sheer excitement of using the law of sines in a side-side angle triangle situation. Let's fill in what we know. I know it's side-side angle. I know in this case it's going to have two solutions. So I'm going to draw my triangle out here, not to scale. I'm going to label in the fashion that I typically label in. And then I'm going to fill in my known information. I know that side B is 15. I know that side C is 13. I don't know what side A is, but I do know that C, angle C, is 50 degrees. And I'm going to use my law of sines again to start filling in information. I'm going to pick sine of angle C over side C because I know those two pieces of information right away, and that'll help out. And I'm going to go ahead and solve for angle B here since I know one of those pieces of information. So again, I'm going to label over here for B, and that's sine of B over side B. Now I'm going to go ahead and fill in my information. I know that sine of 50 degrees for angle C over 13 is also equivalent to the blah, 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 to the ratio of sine of B, angle B, over 15. So I'm going to go ahead and figure out what my sine of 50 over 13 equals real quick. That gives me 0.0589 if I'm rounding it. 0.0589 equals sine of B over 15. So now this is the algebra part that gets much easier. Okay, multiply 15 on both sides so you can clear and isolate this sine of B. And that gives me, if I multiply 15 times 0.0589, that gives me 0.8835 rounded off equals sine of B. And when I know what the coordinate is, when I know what the value is, the way to find the angle is to take the inverse sine of that value, 0.8835 equals angle B. And in this case, when I take the sine inverse of 0.8835, that gives me 62, roughly 0.1 degrees if I round it off. So that means my angle B equals 62.1 degrees. Again, this is where we have to stop and say, hang on a second. Is there another possible angle where this y-coordinate, this sine coordinate, is 0.8853? If I go to 62 degrees on my unit circle, which is about up here, this is 30 degrees, that's 60 degrees, and I were to write out the xy coordinates, or in trigonometric terms, the cosine and sine coordinates, I'm just going to use an x to simplify the x value because we're just not concerned about it. We're using the law of sines right now. And I know that my y-coordinate, my sine coordinate, would be approximately 0.8835. Is there any other angle that, is there any other angle on this triangle that could also have that y value of 0.8835? And absolutely, yes, there is. So what do I do to find out what that angle is? Again, I take 180, I subtract 62.1 degrees. Again, I never trust my arithmetic. I am terrible at arithmetic. If my life depended on it, I would have been dead a long time ago. So I plug it into my calculator just to be sure. There's nothing worse than getting a problem wrong even though you know what you're doing and your arithmetic was wrong. Okay, getting back to the math at hand, 117.9 degrees is the other possible angle here. So this means I'm going to choose my first value here, and what I essentially did was I found out, and I'm sorry, that should have been for angle B, and I'm just going to keep track of what I've been doing here for triangle 1. I'm going to use this 62.1 value here, and then we know that we're going to have to come back and use this later on to find out our second triangle. Okay, so sticking with triangle 1 for the time being, I'm going to use another set of ratios here, and I will probably, again, use sine of angle C over C because I've already solved for it. And now I want to know what my side A equals, right? Well, actually, I'm jumping ahead of myself. First, let's find out what angle A equals. We know that for angle A, for our first triangle here, I'm simply going to add 50 degrees plus 62.1 degrees, and whatever that sum equals, I will take that from 180 degrees, and that gives me 67.9 degrees. Now, I can go ahead and label this here, 67.9 degrees. I know what that angle equals. Now I can use my trigonometric ratios. Get back to where I wanted to be to begin with. I need to find side A for triangle 1. So again, I'm going to use sine of angle C over side C since I've calculated it once already, and then I'm going to equate that to sine of angle A over side A, and when I plug in the numbers, that gives me sine of 50 degrees over 13 equals, I know what the angle is now, sine of 67.9 degrees over side A. And plugging this in, again, I already know that this simplifies down to 0.0589 because I've already done it before up here. And that is equal to, and if you take the sine of 67.9 degrees, you will get 0.9265 if you round it off, and that's over A. Here's the cool, easy algebra part. Multiply both sides by A so we can start to isolate that term A. This gives me 0.0589. A equals 0.9265. Divide both sides by 0.0589, and that gives me a value here. I'm going to plug this in. Believe it or not, I had all this worked out on a piece of paper, and for all the bookkeeping I did, I'm going so fast here, or trying to go so fast in the video, that I don't want to take time to try and find it out because I think it's just going to take me longer. So plugging it into my calculator, again, I get A is equal to 15.7, essentially. All right, so I found my triangle 1. Now, I need to go ahead and solve for my triangle 2 again. So, I'll give myself some more space over here. And if you're interested, this is Microsoft OneNote 2007, and I love it quite a bit. I do have an iPad, but I find that the features are much more feature-rich when it comes to Microsoft OneNote. Okay, so I know my other possible angle for this angle B was 117.9. So what I'm going to do is I'm going to come down here, I'm going to redraw my triangle, I'm going to label it in the standard fashion that I've typically done in these examples so far. Okay, 117.9 degrees was my other angle B. Angle A does not change. That is still, angle C does not change. That is still 50 degrees here. And the rest of our information that we were given in the beginning, side B is 15, side C is 13, and now we are good to go. So first thing I'm going to do is find out what angle A equals. So I take 180 degrees, I'm going to subtract that from 117.9 plus 50 degrees, and that gives me 12.1 degrees. So I can fill that in here, 12.1 degrees. I'm circling these things because that's just like kind of a cue to myself that, hey, this is something I've solved for versus something that was given to me. So if I need to fill it back into a table like I did up here or like I'm going to have to do up here, I could just find it again real easy. All right, so that was for our angle A for triangle 2. So now that I know that, let's see. Really all I need to do now is find side A. So for side A, for triangle 2, let's see, what ratio am I going to start with again? Probably the same one I've been using this whole time. Sine of C over side C. And since I'm trying to find side A, I'll use the sine angle A over side A ratio. And sine of angle C, which is 50 degrees over 13, equals sine of 12.1 degrees over A. And again, I don't like to have to calculate more than I need to. Since I already know what that is, I can just go back up here and look. That's 0.0589. So I'm going to write that down here, 0.0589 equals, and then sine of 12.1 gives me an exciting, awesome value of 0.2096. And it'd be helpful if I could actually write what I say, 0.2096 over A. Cool, the easy algebra parts come back, multiply both sides by A to isolate it. That gives me 0.0589 times A equals 0.2096. Divide by both sides, again, one more time here to isolate the A variable. And by plugging this into my calculator, I get 0.0589, and that gives me 3.6 if I round it out. Okay, so that's basically how you solve these things when you know that there's going to be two solutions. Again, this is meant for practice totally. You can go ahead and fill these things in. I don't really need to do it again. The video is already pretty long. But keep in mind, to refresh or to review, you will have to, in most situations, determine for yourself whether it actually has 0, 1, or 2 solutions. This is done to give you practice to understand how there's two solutions and how you figure those out. Once you get an angle, double check it with your unit circle, find out what that, what that other angle could be, and keep that in mind for your second go-round. And once you've basically got that underhand, then you'll be able to start applying these other things like, okay, well, what if I don't know if it's 2? How do I figure that out? And I did explain it a little bit in the video here, but it's not the purpose of the video. If I feel like I have to go ahead and make a video on that at some point, I will, but I'm pretty busy as it is already. So for my student that this was intended for, I certainly hope this helps you out with the review and all the information that I gave you. And for everybody else, I certainly hope that this at least sheds some light on the calculation portion of it. And if I make some videos in the future, hopefully they'll be of help too. Thanks for watching.